All right, lecture 21 on backup. We talked some about backup from a legal perspective, as in what the requirements are from backup for business continuity, for meeting other legal requirements in one of the discussions. But this is more on the technical side of what are the backup choices and how do you go about doing it. There will be a very easy homework assignment that will come from this. It shouldn't take you more than about 15 to 30 minutes to do. It's an easy assignment. So cold backups. Cold backups really take place in two different fashions. One, you shut down the database, and while the database is down, you copy all of the files from the database to at least a new location on the same system, or preferably to a new computer, so that you can go and start a new database using those files. And that means that the destination computer has to have Postgres installed and ready to work, and then you add this other instance of the database. This means you get all the different databases in there copied all at once. Now, it's really important to remember to actually start the database on a destination to verify that you actually did get all the files. Also, generally speaking, when I do this, I do counts of a whole bunch of critical tables to make certain that I got the same number of rows on the destination. Getting to your destination and restarting from an old copy that you didn't realize you didn't copy the new copy to doesn't do you a whole lot of good. So testing this is a critical piece. Now, the nice thing about this is a way to do other things besides just backup. For instance, this is also how you migrate to new hardware that may be faster. I mean, it may not even be real hardware. You may have done development work and your initial version on an Amazon Web Services small instance, and now you're moving to a large instance that has more capability. But this is also, generally speaking, how you upgrade to a bigger machine. The second kind of cold backup, and this one is used extensively these days, is a thing called taking a snapshot of a file system. Linux has a file system, BTRFS. Some other systems like Illuminos have a file system called ZFS. But primarily this is done with BTRFS on Linux, where you can take a point-in-time copy of entire file systems. BTRFS has lots of advantages, like the ability to store the data duplicated and verify it on different platters, which improves performance, to keep hot files that are used a lot on faster systems, to make backups automatically of file systems. But one of these things is a thing called a snapshot, and that's at a point in time, duplicate an entire file system so that you have a new read-only copy or a new copy to move forward from of a file system. Now, the way that this is combined into Postgres is you can take Postgres and you can tell it that you're about to start a backup, at which point it writes everything out to disk that's cached in memory, and then it stops writing to disk until you tell it that you are done with the backup. So you get a point-in-time copy of the database. So inside Postgres, as an administrator, you tell it, we're going to start a backup. Then at the file system level, you take a snapshot, which only takes under a second, and then you immediately tell Postgres, yes, we're done with the backup. We have the backup complete. Now, in between, Postgres is just stashing everything in memory, so the users don't see that a backup is occurring, but if you were to lose the database, if the system crashed in between, that means that some of their data could have been lost. But since this is very fast, my experience doing this in production is that production systems can do this in under a quarter of a second between the entire start backup, sync and take snapshot, and then turn the database back into normal mode. Because that is so fast, generally speaking, this is a really effective thing. Then you go to the snapshot, which is a complete set of file systems, and you do the cold backup processes where you copy files out. But now instead of waiting maybe hours to copy out a big database, you've got all the time you need. Another thing that can happen with BTRFS, which is really good, is that not only can we do this kind of a backup, but we can do it, and then we can start a new database running on the snapshot. So if your snapshot is set up on a system that is sufficiently got enough power to be able to do this, you can just start a database off of the snapshot. There are a couple configuration files that you're going to have to change that tell it where the files are, because the path will now be on the snapshot instead of the original, but it's quite possible to do this. Now, this is kind of the how I back up the entire system. And remember, you could have multiple databases in a single Postgres instance, and these kind of cold backups, you're backing up the entire instance all at once. Now, both of these things, you've got to remember that there are files in /etc Postgres that you've got to make copies of. The security configuration file, the startup file for the database, all of those files, when you do a cold backup, you need those too. And that's why I say, remember, when you do a cold backup, to start a new database on the destination computer, because when you do that, you find out the files that you're missing and you add those into your process to copy those as well. Now, another alternative, and this is what we're going to do for a very easy homework, is we're going to do a dump of a database using pgdump. Basically, and I'm going to run through this here in the lecture, is you want to be able to do a pgdump of your database. I have a teeny database called Bob, and I'm going to dump that one out in a couple formats and take a look at it. But this is a really common thing. pgdump has a slew of options. My database has a password, which means I'm going to add a -W option to get prompted for the password. You can also run pgdump remotely. You can tell it that your database is one that you can log into at some destination and then have it go across the net to dump it so you get a copy on this system of your database. This is a good way to duplicate entire databases, especially for things like testing, where you want to be able to say, yes, I have this production database, but I'd like to take a copy of it so that I can test with it. It has some disadvantages too. Like everything in computers is a trade-off. The trade-off here is this is not a point in time. As in, if you have a live system and you're doing a PG dump of it, individual tables get locked while it dumps that table, and that has performance implications. And also, you are not guaranteed that across multiple tables that it's going to lock all of these tables all at once. So you can end up with data that is split brain, I think is the term that people use for that, where some of the data in some relationship is there and some other isn't. But generally speaking, pgdump does a pretty darn good job of figuring out which order to dump things in and how to dump them. And for most systems that you're working with, this is a good way to get a quick backup. Now, you figure that between WordPress and Drupal and some other content management systems, that 80% of the internet is running on databases that are probably not that big. I mean, New York Times runs on top of a customized version of WordPress. It's pretty darn big, but that's probably the extreme. But there are a huge number of businesses out there that have a WordPress instance and they run, and they've got, 50K of data in their WordPress, in the database behind their WordPress, or 100K. This makes a really good backup when you combine it with a Linux tool called cron, which is a scheduler. So you can say, every day at 2 a.m. in the morning, take a backup of this database. And your cron has the 2 a.m. in the morning part, and it runs a shell script with some commands in it to dump this and then copy the result of the file off to some other system. So this makes a good general purpose backup for a lot of use cases. It's not what I would classify as a business continuity tool, because to restore it is going to take time. So if you've got something that is in any way time critical, this probably isn't the way to do it. But most businesses, if their website with their blog on it is down for a day, it really isn't going to affect them that much. And you pay a lot for things that are up 24/7. So this is a good middle of the road kind of thing. So let's give it an actual spin. Let's do pgdump -w bob, and let's send the output to bob.back. And let's edit this file. This is actually a text file when it's done this way. And it's worth seeing what's in it. There is a whole bunch of sets at the top. You'll notice that it says that it's a dump. And it has then, here's a create table. And you'll notice that there's alters to get the ownership. And then my little table here, there's only about 5 tables in this database, and they're all teeny, is basically there's the data, and you notice it has a single number 42. Boy, that's exciting data. So in any case, couple observations about the data. By default, when you dump this, it is in text in a format that you can turn around and send back into PSQL to reload it into a new database, into a new in maybe the same instance, but a new database, or into copy this file to a different system and load it on a different system. Now, in terms of security, it is text, which means that if you copy this off to some other location like Amazon storage subsystem, Amazon S3, that you really probably want to protect it by encrypting it. OpenSSH has the ability to encrypt files, but don't lose your password. It's strong encryption. But that's usually a good combination, is you run something with cron, it dumps it, it encrypts it, it copies it off to some other destination where you have a backup. You put the date into the file name so that you know which day it is, so that if you ever have to recover it, you can pick the most recent one. And that's your kind of backup system. And that translates to lots and lots of applications. Now, doing it this way, you're creating one big file. And there are some options on here where you may want to be able to do this, but send the file in a more reasonable format. And the one that I commonly use is this format -T, which says output it in tar format. Tar is a tape archive that's been around for ages on Linux and Unix systems. But this gets you a format that will be a little bit easier to deal with, and it chops up the data into a whole bunch of different pieces inside that single tar file. There are options for compressing it and being able to send a compressed file. It turns out that in lots of cases, it is faster to compress it, copy it, and then if you ever need it back, uncompress it, but the compressed file transfers over the net quicker. So it's actually faster to do the compression and the transfer than it is to just send a file. So that's kind of the pgdump. Here's the kind of a command you'd use to be able to restore a text file. If it's in tar, you want to extract the tar file, and there's a SQL file in there called recover that you'd go into PSQL and you'd run recover, and then it reads in all the other files. So that's kind of the dump a database and be able to get access to it. Now let's talk a little bit about incremental backup. All right, incremental backup. The most common cause of data loss is not computers today. They are way more reliable than human beings. The most common cause of data loss is somebody going in and deleting data or dropping a table in a database when they shouldn't. And what you'd like to be able to do is to be able to recover the database up to 1 second before this event happened, so that you can get as much data as possible. This happens in lots of ways. And, I have seen system admins have an error in deleting files, and they typed the wrong thing, and they deleted one of the database's files off the system. I have seen database administrators drop tables when they think they're on a test database, but they're on production. Lots of different ways this can happen. Now, this kind of an incremental or point-in-time backup requires some sort of a tool that can get you to that spot. And the one that I use is Barman. There's another one called Amanda that I have not used that does a similar kind of a job. Barman is maintained by a company called Second Quadrant. It's a Python program. It has some nice features. It's not perfect, but it is useful and it works. And it is well maintained. Second Quadrant is basically a Postgres database backup company. That's what they do. And they use their own tools. So it handles multiple different targets, as in if you have 5 different Postgres instances on different machines, it works well in that kind of a scenario. You can basically set it up so that you get near zero data loss under most scenarios, or if you lose machines, you get zero data loss. It is set up for doing streaming between machines. And Postgres has a built-in system of a thing that it calls wall files. And these are, as it makes changes to the database, files that it writes out so that another database in continuous recovery mode can pick these files up and bring them in. Now, your continuous recovery database becomes your backup live database, a hot backup. that it's sitting there running, waiting to be told that it is the primary. So if the original primary database has something goes wrong with it, the computer fails, the data center loses connection to the universe, you have this other one that is ready to go, that is within, I don't know, I've set this up so you've got them on different coasts. One in Amazon US East one, which is out in Virginia, and one that's out in the Bay Area in Amazon US West one. And using these WAL files, I can keep them within about a quarter of a second of each other over that distance. So, this is pretty close to a real-time backup. It's not 100%, but it is very, very close to being 100%. So, Barman works well in this kind of scenario, and it allows you to do backups of these WAL files. So what you do is you start out with a cold backup, and then as the database is running, okay, it's making all of its changes in these files. Barman is running and making copies using a tool called rsync to sync this data off to a destination, as well as you've got a hot backup. And if something goes wrong, you run some commands that turn the hot backup into the primary database. Now, usually what this requires is that your application server, the stuff like we wrote in Python, has to have some knowledge in it about how to reconnect to a new primary database. So it's going to require some, but not excessive changes in whatever is your application to be able to support this. And there are plenty of applications that are built out there for Postgres that have this built into commercial applications. So they're expecting this kind of a thing. Now, usually this requires a heartbeat, and there are open source packages for a heartbeat where the backup database is continuously checking that the primary is actually up and running. And if it isn't, it will immediately go into a recovery mode and become the new primary database. There is documentation. I have a link there in the notes to the documentation for the most recent release of Barman. And let me give you a diagram here that describes what this pair of databases looks like. This is taken from the Barman documentation. But you've got an original Postgres database. This is where all of your stuff is happening. And it has a connection that goes to a backup database and continuous recovery. There's a streaming backup, and it takes some configuration to get this working. And these WAL files are streaming through to the destination backup database. Now, there is another thing that they use one of these backup databases for. Since it has basically a read-only copy of the original, you can run all of your selects on it. And with some configuration to make certain that those things are asynchronous, usually they're closer to each other than across coasts, but next to each other so that they're in very high-speed synchronization, you can actually extend the capabilities of Postgres, the performance, by having a bunch of these backups, say 10 of them, and all your select statements, which usually a database runs about 90% select statements, they go off to the backups. All of your big reports that take time to run, they run on the backups, as opposed to the primary database that only does the insert, updates, and deletes. So this is reasonably complicated to set up, but people like Amazon Web Services have this set up and pre-built with everything in place. Amazon Aurora does this with a primary, and you can determine the number of backup continuous recovery ones that you have, and you get something that for a price you can run, 500,000 to 1 million transactions a second out of the box. If you pay them enough money, you can have it set up this afternoon. And it's all configured with backups, everything in place, ready to go right now. So, if you've got an application that needs that and you've got deep enough pockets, you turn it on, you run it. There are other companies out there that also do this besides Amazon Web Services that are very good at it for running hosted Postgres databases with backup and everything in place. So this is a good way to be able to get databases running with backups, and it takes some configuration. It takes some time to set this up. This is definitely one of the things that we're going to cover in a graduate level database class next time if I teach it, and setting up one of these automatic continuous recovery databases and working with some of these tools like Barman directly for doing backups. Now this takes quite a bit more stuff than what we've had in this class. you definitely end up with multiple virtual machines, which means you're going to have a system that can do that to run these machines, and it takes time and effort to set these up. So this is a much more complicated setup. Now, the last assignment in the class is going to be able to take your database from assignment 4 and run a quick backup of it with pgdump and make certain that you can actually run this and see how it works. Nothing real exciting there. It's not a creative assignment. It's just run some things and get some files. So it should be pretty quick and easy. It's stuff that's built into Postgres. But it should be something that you're familiar with so that you can, use this for other things. You want to do tests and you want a copy of a production database so you can test on. You've got a way of doing it. That kind of brings to an end for the semester the content for this class. We are going to have a lecture that's a review for the final. The final is going to be similar to the midterm, but easier because the final is only 200 points. The midterm was 300. And the grades for the interactive stuff I will have posted here in the next week or so. That was just a go through and complete the pieces, so you should get, 500 points out of it. And with that, I, stay safe, have fun. I'm looking forward to the final. I believe I will have the final due on in the middle of finals week, or the Thursday of finals week, actually, which I think is the 13th. So I don't know what I said in the syllabus, but it will be due the 13th at midnight. So you have most of finals week, and I will have it out before the first day of finals. So you will have it available to you. Again, it's going to be 4 short answer, half page to page written answers on questions about things in the class. So I will do a review of those specific things, and we will catch you later.